It's 2024, and the Bridges exhibition of mathematical art is happening soon in Richmond, Virginia. I've got a piece, and I want to show it to you. This is the piece, and what it looks like inside the catalog. And these are my samples of the pieces, even though I don't have it in my possession at the moment. Here's a sample of them. What it is it's a compound of two cubes with its convex hull and its common solid. And these are known forms. So why put them in the exhibition? Well, there's a couple reasons. One is that so people can handle it. You don't generally get to handle a compound of two cubes. And it's kind of wonderful to see how as you turn it, you can see one cube, but you turn it another way and you see the other cube coming out of it. So handling these is just different than seeing pictures of them. Also, there's some hidden surprises in this. One of the surprises you get to see has to do with hexagons. Now, if I took a cube, just a regular cube that had nothing coming out of it, and I cut it along all in the middle of each of these edges going around, if I cut it and then took it apart, you would see that it has hexagon described inside, and it's a regular hexagon. All these sides are equal. Well, this compound of two cubes does that. It divides it in half. So the things that are its common volume and its convex hull will echo that hexagon. And here's what I mean. So here's my larger one. Here's the convex hull. The one in the exhibition has a little magnet here to hold it in because it's much easier to do that, open it up, than do what I like to do, which is slide it inside. Now, that really just doesn't come apart. There's no magnets or anything. It's just friction that's keeping it there. And it's actually hard for me sometimes to find where does it open. And I love the way that it opens by splitting apart. And you see the compound of two cubes inside. Okay, so there's my compound of two cubes. It fits like a glove. And look, you can see, again, the hexagon, the surprise hexagon inside. These are flaps to help hold it in. But you can see that's a hexagon shape. Okay? Then again, it's a regular hexagon. Now, here's my compound of two cubes, and I want to get to the common solid. How do I get this apart? Well, this is sort of held together by magnets. I'm going to just pull it apart gently. And there's a couple magnets inside of each edge, and that holds the piece together. And again, there's the hexagons. Okay? So here's the common solid. Again, hexagon. And, well, we opened our convex hull. We opened up the compound of cubes. So naturally you want to open this up too. So what's the best way to get this to open? And I love the way this opens. I press on the vertices, and there it is. It opens like this little pouch. Oh, and there's something inside. You can see the paper clips. Those paper clips will catch on the magnets inside of here. So I don't know. I don't put it in a certain way. It doesn't matter because I put the paper clips everywhere. And there's little something inside of these. And what's inside of these is the map or the template or the net of the that I use to create these forms. So they're all hidden inside of here. And this goes back together. Again, it just stays together with friction. Sometimes it gets caught on the paper clips. There it goes. And it goes back together. In this show, there's one that's just there for exhibition. It doesn't come apart. But there's also one that is off to the side that people are invited to take apart and put back together again. So, hope you enjoyed that. I love this. Okay.